Hey, welcome back again to Number Sense Academy, and today we're gonna look at circles. So let's just jump into this right quick. So we are talking about circles, and really quickly, we know that we could create sketches of circles, and just like any other curve or any other object that exists in the Cartesian plane, circles could exist anywhere. Now, depending where they are, there's certain properties that get changed or are different. So if we look at this circle here, we see that the center, even though it's poorly drawn, the idea is that the center of it is at the origin. So now imagine that I took this circle and I translated it, or I moved it over somehow. I got it over here. It would also have a center, and what would have changed is the location of its center. Yep, we went from here to here in some direction of x and some direction of y. Okay. The other things that also changed is the boundary points, or the points on the outer edge of the circle. These also changed. So this is going to be very important in how we evaluate some of these circles. So one of the main differences, as I highlighted, is the fact that the center is different. Because the center is different, the equations that we use will be different. So if a circle has the origin at 0, 0, then the equation for the circle is x squared plus y squared equals r squared. And if the circle is not doesn't have a center at the origin, then the equation that we use is x minus h squared plus y minus k squared equals r squared, where h k is the coordinate of the center. Now, you should be able to see that these two formulas are the exact same. Now, and how I'm going to demonstrate it is if if hk represents the center and I have this equation, what would it look like here? Well, we know that the origin is at 0, 0 here, and that would be h and k. So for this one, I would have x minus 0 squared plus y minus 0 squared is equal to r squared. X minus 0 is just itself. Y minus 0 is just itself. So I'd still end up with x squared plus y squared equals r squared. So the main thing is that both of these formulas are the exact same. It's just that one, the origin, the origin is the center, which is at 0, 0. And here, the origin is not the center, and it is at hk. One more thing I'm going to point out about h and k is that we say, so it's x minus h squared plus y minus k squared equals r squared. You notice that here we're subtracting h. We're subtracting h. Here we're subtracting h, but we say it's h and k. This means that we're taking the negative of the values. Okay, so if I have an equation, I'm going to do a quick example. So suppose I have x plus 3 squared plus y plus 4 squared equals, say, 36. Then the center is, so where it's h and k, it's going to be minus 3 and minus 4, because we're taking the negative. If I have another example where I have x minus 2 squared plus y minus 5 squared equals 100, then h and k in this case is 2 and 5. So you always just take the negative. I'll give one last example. So if I have x plus 7 squared plus y minus 5 squared equals to 49, then h and k are negative 7 and 5. So these represent the centers. And if you have equation in this form, then you could find a center and you can begin to graph your equation or graph your circle. Now, where does this r come from? So r is the radius. R is the radius, and if I have a circle that has center at the origin, then the radius represents it's a segment or vector from the origin to the circle, to the outer edge of the circle. Okay, the radius is the same regardless of where you end up on the circle, as long as you start from the middle. The radius is all r. It's the same. It's the same value. It's the same r. Now, the way that that's calculated, so this point is a combination of an x, y value. It's a coordinate. How do I get there? Well, I go in a direction of x, and then I go in a direction of y. So this is y, this is x. And just by that, we could use Pythagorean's theorem to find the length of the diagonal, which is x squared plus y squared equals r squared. Right? So x squared plus y squared equals r squared. X and y will not be the same as the radius. However, the radius, the x-intercept, or the this is the y-intercept, and the x-intercepts, if it's coming from the origin, if the circle has a center at the origin, then the x-intercepts, the y-intercepts, will be the same value as the radius. So if center at origin, x-intercept, y-intercept will have or will be same distance or length as radius. The reason why I want to say this, because in this quadrant over here, y and x are positive, so it'll be the same value. But in this quadrant, like these two values or these 2 points will have negative x and negative y. But over here, you have positive x and positive y. And that leads to another important point, is that if the center is at the origin, and you know if center is at the origin, and you know one point, say it's xy, then you could just use symmetry to find the other points. And the other points will be, when I say the other points, I just mean some other points that you could use to graph your circle. You're going to have negative x, negative y. So it'll be somewhere in here. You're going to have x, negative y. So it'll be somewhere in here. So in this quadrant, then you'll have negative x, y. So that'll be somewhere in this part of this quadrant. And of course, x, y is in this part of the quadrant. So that's just to help you graph if it's easy, make things easier. If it's not, if the circle's not in the center, or if the circle doesn't have the origin as its center, then this won't be the case. So you got to be very specific. It won't apply here. Okay. So I just want to leave one more note about H and K if I wasn't specific. So if center is not at origin. So if you think about, and I said this at the beginning, but I'll just reiterate it. If I have a circle that's sitting at the origin with radius r, and I take this circle and I just move it, and it ends up here, and it still has radius r, then there was some transformation that I did to make this move. And the transformations were starting with, like I said, to the origin and then to the outer points. So I took the origin, I moved it in the direction of x, and then I moved it in the direction of y. So here's just some rules for you to figure out where, if you're doing a translation of circles or you get an equation in x minus h squared plus y minus k squared equals r squared format, then these four things will help. So one, if h is negative, then go in positive direction of x. If h is positive, and let me just read it. So if it's negative, then I'm going this way. Okay, I'm moving my circle that way. If h is positive, then go in the negative direction. All right, so if you have x plus 3 squared, then you go this way. Go this way. So this is for h and x. So if k is negative, then go positive direction of y. So in this case, we're going up, and likewise, if k is positive, then go negative direction of y. So we go down. So for this example, what we did was we went left and downward, right? So that means h was positive and k was positive. So both, because that's how we end up with a negative. In the quadrant, both of these values are negative. So that's one thing to keep in mind. So just do the opposite of what's given in the equation. Okay, so let's look at some quick examples. Example 1. Find the radius, state the x and y intercepts, and sketch the graph of the following. So the equation is x squared plus y squared equals 36. So we're going to find a radius. So the first thing we're going to look at, we know that x squared plus y squared equals r squared. And if I look at the equation given, I have x squared plus y squared equals 36. So if I match these up, x squared is x squared, y squared is y squared, that means r squared is 36. So r squared is equal to 36. And I solve by finding r is equal to square root of 36. R is equal to 6. Now, let's pause for a second. Very important. The radius is length. Okay? So length has to be positive. Must be positive. So I'm just going to keep a note of that, and then I'll explain why I even mentioned this. So we found a radius. Now let's find the x and y intercepts. So for the x-intercepts, so let's go x-intercepts, we're going to let y equal 0. So I have x squared plus y squared equals 36. If y is 0, I have x squared plus 0 squared equals 36, which means x squared equals 36. And x is equal to the square root of 36, and x is equal to plus or minus -6. So I have these two values, right? And this should make sense because -6 squared, if you plug it into your calculator, -6 squared is 36, and 6 squared is also 36. So these are two roots. All right, what about y? So for the y-intercepts, we let x equals 0. So I have x squared plus y squared equals 36. So I have 0 squared plus y squared equals 36. I have y squared equals 36 left, and y is equal to the square root of 36. And I have y is equal to plus or minus 6. So if you look at this equation, we're not surprised that the absolute value, or the measure of the radius is equal to the positive values of x and y, because it goes through the origin, right? There's no x minus h plus y minus k. It just means that h and k are 0. Now, the reason why I didn't take plus or minus for the radius is because it is a measure of length and it has to be positive. So when we're dealing with measures like volume, length, we don't take the negative values. However, when we're dealing with coordinates, because these x-intercepts and y-intercepts, we do need the coordinates. So the coordinates that come out of these are, we're going to have, when y is 0, we're going to end up with 6 and 0 and -6 and 0. And then when x is 0, we have 0 and 6 and 0 and -6. Okay, so two things done. We found the x and y intercepts, and now we're going to sketch the graph. This is the last part. So quickly, we don't have to make this fancy. We know this is y and x. And I'm just going to just put the points I need on the graph, and hopefully it's properly measured. So this is -6, -6. So I know that my y-intercept, the first one's there. The second one is here. My first x-intercept is there. My second one is there. So now I just do my best to draw a circle, even though this looks like anything but. And I know that my center is at the origin. All right. Okay, next question. So a circle passes through the origin, or it's not worded properly. So a circle has center at the origin and passes through the point 6, 8. So we need to find the radius and just write the equation. write the equation of the circle. So let's find the radius first. And while we do that, we're going to see that we actually can accomplish both. So we start with x squared plus y squared equals r squared. So x, I'm going to take this value for x and this value for y. So I end up with 6 squared plus 8 squared equals r squared. So r squared is going to be equal to 36 plus 64. R squared is equal to 100. I'm going to circle this because I'm going to come back to this later. As I progress, I find that r is just the square root of 100 and r is equal to 10. So this is my radius, which is great. I found my radius. So find the radius. Now we have to find the equation. Remember, the equation is this format, so x squared plus y squared is equal to r squared. What I need is a value for r squared. So I have that. It's right here. So I have x squared plus y squared equals 100. And that is the same as x squared plus y squared equals 10 squared, right, for r squared. And then I'll just solve for 10 squared to get 100. So that's my equation of the circle. Next question. So a circle passes through the points -4, -3, and 4 and 3. Find the radius and the equation of the circle. So we got to make a couple assumptions here to make this easy. If we don't make these assumptions, then the question becomes much more difficult. So because we know that if a circle has the center at the origin, then once I know one point, then I can figure out the other points, right? If I know this, then I know the other points are as follows: -x, -y, -xy, and x, -y. So I'm given this as 4, 3. So that's that point. When I look at -4, -3, it fits this bill. So because of that, it passes through the origin. Or it has a center at the origin. So with that information, I don't need to do any extra calculations. I could keep it as simple as possible. So let's find the radius. So the radius we know is r squared is equal to x squared plus y squared, which means that r is equal to the square root of x squared plus y squared. And you should recognize this formula. This is the distance formula. Remember, distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Well, if it's going through the origin, that means x1 is 0 and y1 is 0. So I have d is equal to x2 minus 0, it's just itself, so that's x2 squared plus y2 squared. These are the exact same formulas. Okay, all right. So I just put that there just so we can match those up. So now we can continue solving, and r is equal to, so I'm using, you could either use 4 and 3 or -4, -3, doesn't matter. You just got to pick one. You can't, yeah, just pick one. So I have 4 squared plus 3 squared. 4 squared is 16, 3 squared is 9, square root of 25 is 5. So r is 25. And then the equation Now I write down my equation. So we just found the radius. Need to find the equation. So I have x squared plus y squared equals r squared. I know I'm flipping back and forth, but it doesn't matter. It's commutative. I'm adding. It doesn't change anything. So I have x squared plus y squared equals r squared. I know what r is. So I have x squared plus y squared equals 5 squared, because I know what r is. So my equation is x squared plus y squared equals 25. And I found the equation of the circle. Yay. All right. Next example. So a circle has center 2, -3. So its center is located at 2, -3, and its radius is 9. So 9 units. We're going to find the equation of the circle and then sketch it. And sketch the circle. Circle. All right. So the equation. So because the center is not at 0, this is not at 0, 0. So we have to use the form x minus h squared plus y minus k squared equals r squared. And we're given the radius. So we have everything that we need. So h is 2. This is h and k. So I'm taking these values as is, and I'm going to plug them in. So it's going to be x minus 2 squared plus y minus 3 is going to be y plus 3 squared equal to 9 squared. So I always solve for the, you want to solve for the radius. You get x minus 2 squared plus y plus 3 squared equals 81. Okay, now graphing is going to be fairly straightforward. I have, so first I'm going to do is locate, so I got to make this graph a little tiny, so 2, because all I'm going to do, I'm going to find the center of the circle. Once I find the center of the circle, then I'm just going to do some easy transformations to get the value that I need. So the center of the circle is at 2 and -3. So that's 2, -3 is about here. Okay, that's the center of the circle. And I just need to find the outer edges. I just need about 4 spots. So all I'm going to do, remember the radius extends all over the circle. So it doesn't matter where, like this is the radius, 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 this is the radius. So I'm just going to find the top, the bottom, the left, and the right. That's all I need. So what that means, I'm going to start at the origin. I'm going to go up 9 in the direction of y. So I'm going to go from -3 up 9 spots. So 1, 2. So starting at -3, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then so it's going to be -3 plus 9 is 6. So it's going to be at 2 and 6. This is my, right, 2 and 6. Because -3 plus 9 is 6. Okay, so that's my top point. For the point to the left, I'm going to take 2, which is my x value, and I'm going to add 9 to that. So that's going to be 11. So let's see, what do I need? I have 1. How many points I have here? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 11 and 12. So I'm going to go in that direction. 1, 2, 3, 4, 5, 6, 7. Sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9. Boom. Right there. Obviously, it's not scaled. It's not going to be pretty. So if I'm at -3 and I need to go down 9, so I'm going to go down 9 units. So in the direction of the y, so this is going to take me to 12 or -12. So let's make sure I have enough. 1, 2, 3, 4, 5. Sorry, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's going to be around here. So I'm going to put that here. And this is not very well drawn. I apologize. And then in the other direction, I'm going to go 9 units as well. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's about here. So this doesn't look properly scaled. So let me just count this properly. So from here, I need to go 9 units to the right. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. From here, I need to go 9 units down. 1, 2, 3, 4, 6, 7, 8. No. 1, 2, 3, 4, 5, 6, 9. So there. Okay, yeah, that makes a little bit more sense. And then here I have 1, 2, 4, 5, 6, 7, 8, 9. Yeah, it's a little bit better. So this point, it should not be there. So then I connect it. And if it was scaled properly, it would work out. So basically, all you're doing is you're going in the x direction. You're going to add 9 units. And in the y direction, you're going to add 9 units. For the positive side, and for the negative side, you're going to minus 9 units. And for the negative side, you're going to minus 9 units. If your graph is nice and scaled, you get something that looks a lot better. Okay, and then our final example. So we have a circle with endpoints -4, 3, and 8, 8. So we need to find the equation. Okay? So we don't have the center. We don't have the radius. So we're going to have to go out and figure these things out. So just in the previous example, we guessed that it went through the origin. This doesn't look like it goes through the origin, or else we get something that looks like -4, -3, or 4, -3, or -4. We have -4, 3, or 4, 3. So this clearly doesn't go through the center. So we have to use what we have to figure this out. All right, so let's use our tools. So we need to find out the radius. So if you know about circles, these, and I could graph it, but I don't want to graph it. So what we can do is, if these happen to lie across from each other, then we could find the diameter, right? The diameter is the distance across. Not only that, the half of the diameter is the radius. So the diameter is equal to 2 times the radius, or the radius is just a half of the diameter. So once we find the diameter, we could take a half of it and then we have our radius. How do we find the length of the diameter? Well, you guessed it, we're going to use our distance formula. So the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. So let's go, we're going to go x1, y1, x2, y2. So I have 8 minus 4, which is going to give me 8 plus 4 squared. And then I have 8 minus 3 squared. So this is, I have 12 squared plus 5 squared. This gives me 144 plus 25, which is 169. Then the diameter is 13. And the radius, which is half of the diameter, is going to be 13 divided by 2, which is 6.5. So I have a radius of 6.5. Okay. The other part is, so the radius is 6.5. So I don't know, we're not given the center, so we have to figure out what the center is. The center is also the halfway point in the diameter, so I could use the midpoint formula to actually find the center. And then I could use that to firm up my equation. So if you remember, the midpoint formula is x1 plus x2 divided by 2, y1 plus y2 divided by 2. So I have 8 minus 4, okay, or it could be negative 4 plus 8, whatever you divided by 2. And then I have 8 minus 3 divided by 2. So this becomes 4 over 2, and this becomes 5 over 2. Wait, sorry, no, that's wrong. 8, yeah, 8 plus my, yes, because we're adding. And this is wrong, so it's 8 plus 3, so this becomes 11 over 2. So that's where the mistake was. So I have 2 and 11 over 2, and 6.5. So I could leave it as 13 over 2, or I could write it as 6.5, which means I could write this as 2 and 5.5. So I have everything I need for the equation. So my equation is going to be in x minus h squared y minus k squared equals r squared format. So x, h we know is this, and k is this. So x minus 2 squared plus y minus, let's go with 5.5 squared is equal to 6.5 squared. 6.5 squared is, let's figure that out real quick. 6.5 times 6.5 is, well, 42.25. So that's how we're able to find the equation given the endpoints of the circle. Okay. So we calculate the distance because we're only given these points. So we calculate the distance, and then from there we're able to find the radius. So that's important for the equation. Then to find the center, we just found the midpoint of these 2 points. And there you have it.